Good morning, my dear students. Welcome to my physics class. Our today's topic is Newton's third law of motion. Let's start now. Newton's third law of motion. When an object applies a force on another object, then that object also applies a force of equal magnitude on the first object but in the opposite direction. This is the statement of Newton's third law of motion. That means if an object apply force on another object, then that object will also apply force on the first object but in opposite direction. Consider A and B two objects. A objects apply force on B objects, and therefore B object will also apply a force on A object, but the direction of these two forces is opposite. Consider this force is the action force, that means force applied by A body on B body, and this force is F1 force, and this force is known as action force. And B object will also apply force on A object, so F2 is the reaction force. F1 is the force applied by A object on B object, therefore B object will also apply F2 force on A object, and we know the direction of F1 and F2 is opposite to each other, and the magnitude of these two forces same. That means F1 is equal to minus F2. F1, the magnitude of F1 and F2 is same, but the direction is opposite, so here minus sign. F1 is equal to minus F2, that is F1 is opposite to F2. So we can say it, to every action there is an equal and opposite reaction. Action force means the force applied by A body on B body, and according to Newton's third law of motion, B body will also apply a force on A body, and this force is reaction force F2. The third law states that if there are two objects A and B, then when A exerts a force on B, then B also exerts a force on A. There is another example of Newton's third law of motion. That is, if we apply force on a wall by our hand, then the wall will also apply force on our hand. That is, force applied by us is action force, and force applied by the wall on us is reaction force, and this action and reaction force is equal, but direction is opposite. Action and reaction force does not cancel each other because these two opposite forces act on two different objects, never on a single object. Remember it, action and reaction force does not cancel each other. We may think action force may be cancelled by the reaction force, but action and reaction force does not cancel each other, because action force acts on a body and reaction force acts on another body. These two forces act on two different objects, never on a single object. If these two forces acts on a single object, then these two forces may cancel each other. Consider here F force, two forces of magnitude F acted on this single object, but their direction is opposite to each other. Therefore, these two forces may cancel each other. They can cancel each other because they are acting on the same body and in opposite direction, So if these two forces acted on same object but in opposite direction, their magnitude is same, so they can cancel each other. But action and reaction force acts on different objects. That is, A object applies force on B object. This is the action force F, and according to Newton's third law of motion, B object will also apply force on A object, and this force is this F. So these two forces act on two different objects, so they cannot cancel each other. Here an example of action and reaction force. Here there is a attraction force between earth and this apple, and we know, consider the mass of the apple is m and mass of the earth is capital M, and there is a attraction force, that means gravitational force, between earth and apple. Consider the mass of earth is capital M and the mass of apple is small m. We know that due to the earth's gravitational force, the mass m experiences a force F towards the center of the earth. That is, the earth will apply force on this apple, and this force is towards the center of earth, and magnitude of this force F is equal to G capital M small m divided by R square. R is the distance between earth and this apple, and this force is also can be written as F is equal to mg. We know force F is equal to m into g. Here m is the mass of the apple and g is the acceleration due to gravity. That means the earth attracts the apple towards the center of the earth by this force, and the apple also apply force of same magnitude F on the earth. That is, the apple attracts the earth towards the apple by this F force. Earth attract this apple with this force, and apple also attracts the earth towards the apple. So F is equal to mg. Acceleration of earth due to the force applied by mass m. We know there is a gravitational force between earth and apple. Earth attracts the apple towards the earth by the force F, and also apple attracts the earth towards the apple by the force F. Now we know the acceleration of apple will be g. This is the acceleration due to gravity. Now what will be the acceleration of earth? Now we will calculate it. Force applied by mass m, that means by apple on earth, F is equal to mg. We know these two forces is same. Force applied by earth and force applied by apple is same magnitude, but their direction is opposite to each other. We know F is equal to m into a. We know F is equal to ma from Newton's second law of motion. F is equal to ma. Here F is the force applied by apple on the earth, and capital M is the mass of earth, and a is the acceleration of earth. Now we will calculate this acceleration. Acceleration a is equal to F divided by m, or a is equal to mg divided by capital M, or m divided by capital M into g. If m is equal to 1 kilogram and capital M is equal to 5.98 into 10 to the power 24 kilogram, then the acceleration a is equal to small m divided by capital M. Small m is equal to 1 kg and capital M is equal to 5.98 into 10 to the power 24 kilogram into G 9.8, and after calculation A is equal to 1.6 into 10 to the minus 24 meter per second square. This is the acceleration of Earth, and this acceleration is 1.6 into 10 to the minus 24. This is very small magnitude. This is so negligible that nobody is bothered about it, and this acceleration is very negligible. So this apple cannot displace the earth, but earth can displace this apple. So apple moves towards the earth, never the earth moves towards the apple, because the acceleration of earth is very negligible, but the acceleration of apple is 9.8 meter per second square. Therefore apple and earth attracts each other with the same force, but the acceleration of the apple is more than the acceleration of earth, because the mass of apple is very small but the mass of earth is very large. Therefore apple moves towards the center of the earth, never the earth moves towards the apple. Now look at the picture. Our walking mechanism: when we walk, we apply force on the ground. When we walk, we exert a force on the ground. That means we apply force on the ground, and this is the force. F force is applied on the ground by us, and according to the Newton's third law, the ground also applies an equal and opposite force on our body. This F force is the action force, that is force applied by us, and the ground will also apply a force on us, and this force is minus F, because these two forces is opposite to each other. This equal and opposite force creates the acceleration, and we walk. We can walk by this reaction force applied by the ground on us, and this force creates an acceleration, so we can walk. And look at the picture. Suppose you are standing on a totally frictionless surface. Your mass is 50 kg, and there is a stone of mass 100 kg in front of you. You have decided to push the stone with a force of 50 Newton and will move it from one end to other end. What will be the velocity of the stone after 10 seconds? We have to calculate it. The mass of the stone is 100 kg and mass of you is 50 kg, and you are applying force on this stone, and the magnitude of your force is 50 Newton. So by the application of this 50 Newton force, the stone will move. We have to calculate what will be the velocity after 10 seconds. The acceleration of the stone towards right, here force is applied from left to right on the stone. So the stone will move from left to right. By the application of this 50 Newton force, here force is 50 Newton and mass of the stone is 100 kg. So the acceleration of the stone towards the right will be A is equal to F divided by M. Here F is equal to 50 Newton and mass of the stone is equal to 100 kg. This is equal to 0.5 meter per second square. So acceleration of the stone is 0.5 meter per second square, and its direction is towards the right, from left to right. And according to Newton's third law of motion, the stone will also apply force on you, because you are applying force on the stone. This is the action force, and this stone will also apply a force on you, This is the reaction force. And as you are experiencing a force of same magnitude 50 Newton, you are applying force 50 Newton on the stone will also apply 50 Newton force, but in the opposite direction, that is from right to left. The force applied on you is from right to left. The acceleration of u towards left, a is equal to f divided by m. This is equal to 50 divided by 50. Your mass is 50 kilograms, so here 50. This is equal to 1 meter per second square. Your acceleration towards the left is 1 meter per second square, and the acceleration of the stone from left to right is 0.5 meter per second square. But your acceleration is more than the acceleration of the stone, because your mass is 50 kilogram, which is less than the mass of the stone, and the mass of the stone is 100 kilogram. Therefore the stone and you will move in different direction. Acceleration of the stone is from left to right, and your acceleration is from right to left, so you will move towards the left direction, and the stone will move towards the right direction. Therefore the stone and you will move in different directions, so it is not possible to push the stone non-stop for 10 seconds. So you cannot apply force non-stop for 10 seconds, because you and stone will move into different directions. Therefore a distance will be created between you and stone. The acceleration of the stone towards right, a is equal to 0.5 meter per second square. The acceleration of u towards left, a is equal to 1 meter per second square. Let us consider you pushed the stone for 2 seconds. What happens then? If you apply force on the stone for 2 seconds, then what will happen? After 2 seconds, the velocity of the stone v is equal to u plus at. We know acceleration of the stone is 0.5 meter per second square, and u is initial velocity of the stone, and stone is at rest position, so u is equal to 0. Therefore 0 plus 0.5 a, and t means 2 seconds here for 2 seconds, so this is 1 meter per second. After 2 seconds, the velocity of the stone will be 1 meter per second, and after 2 seconds the stone will move with uniform velocity of 1 meter per second, as the surface is frictionless surface. So when the stone start to move, then it will move with the uniform velocity, and this uniform velocity is 1 meter per second. After 2 seconds, the stone will move with uniform velocity of 1 meter per second. And after 2 seconds, the velocity of u v is equal to u plus at, and u is equal to 0 initial velocity, because you are at rest position initially. So 0 plus acceleration of u 1 meter per second into time t. This is 2 meter per second. That means after 2 seconds you will move towards the left direction with uniform velocity 2 meter per second. So after 2 seconds the stone will move from left to right with uniform velocity 1 meter per second, and you will move from right to left with uniform velocity 2 meter per second. Now mathematical problem. Another mathematical problem. If 150 Newton force is applied on a rest body of mass 50 kg for 3 seconds, what is the distance traversed by the body in 10 seconds? Here 150 Newton is Newton force is applied on a body of mass 50 kg, and duration of applying force is 3 seconds. We have to determine the distance traversed by the body in 10 seconds. Remember it, force is applied on this object for 3 seconds only, so acceleration of the body will be for 3 seconds only. After 3 seconds it will move with uniform velocity. There is no force, there is no acceleration. Remember it, there is no force, there is no acceleration. If there is no force, the object will move with uniform velocity. So here u is equal to 0 meter per second, the rest body. So initial velocity u is equal to 0 meter per second. Applied force F is equal to 150 Newton, and mass of the body is 15 kilogram. So it is 15 kilogram. A is equal to what? We have to determine the acceleration of the body, and what is the distance traversed by the body in 10 seconds. And we know A is equal to F divided by m. Acceleration is F by m. So applied force F is equal to 150 Newton, and mass of the body is 15 kilogram. So acceleration is equal to 10 meter per second square. This is the acceleration of the body. As the force acts for 3 seconds, the body moves first 3 seconds with acceleration 10 meter per second square. That is, during this application of force, that means for 3 seconds the body will move with acceleration 10 meter per second square, and after 3 seconds it will move with uniform velocity. After 3 seconds it will have no acceleration. After 3 seconds it will move with uniform velocity, and after 3 seconds this uniform velocity v is equal to u plus at. We know v is equal to u plus at. U is the initial velocity and this is 0, and a means acceleration 10 meter per second square, and time t is equal to 3. So after 3 seconds velocity of the body will be 30 meter per second. This is the uniform velocity, and after 3 seconds the body will move with this 30 meter per second uniform velocity. Now initial velocity is 0, F 150 Newton, mass 15 kilogram. Acceleration of the body is 10 meter per second square. We have determined it, and velocity after 3 seconds is 30 meter per second. Now we will calculate the distance traversed by the body in 10 seconds. And in 10 for 3 seconds the object moves with acceleration, and next 10 minus 3, that is 7 seconds, the object moves with uniform velocity. That is, 3 seconds moves with acceleration and 7 seconds moves with uniform velocity without any acceleration. So for first 3 seconds we will calculate for first 3 seconds S1, distance traversed by the body for first 3 seconds. That is, during this time it will have acceleration. So the formula will be ut plus half at square. There is the acceleration. Initial velocity is 0, so u into t, 0 into t is equal to 0, plus half into a means 10, and t square, that means time square, 3 square, and after calculation it will be 45 meter. And for remaining 10 minus 3 is equal to 7 seconds, and rest of the time 10 minus 3 is equal to 7 seconds, it will move with uniform velocity, and therefore S2 is equal to Vt. If the object moves with uniform velocity, then S is equal to Vt. So S2 is equal to V into T. This is 30 into 7. This is equal to 210 meter. That is, during uniform velocity it will move 210 meter, and during acceleration it will move 45 meter. Therefore total distance traversed by the body in 10 seconds, S is equal to S1 plus S2. S1 means distance traversed by the body in 3 seconds, and S2 means distance traversed by the body in 7 seconds. So in 10 seconds total distance S1 plus S2, 45 meter plus 210 meter, this is equal to 255 meter. This is the total distance traversed by the body in 10 seconds.